Good afternoon, evening. Day 11 here in our graphing unit, and we're looking at sine and cosine shifting uh, or transformations as we call them. And we looked at how the amplitude was affected the other day, and we looked at how the period was affected. So we have two more to look at today. We're going to be using Desmos again to help us out, and we'll be summarizing those like we did last time. So let's get up what we're going to do today on our Blackboard here now that it's open. Okay, so this is day 11. This is part 2 of the cosine and sine graphs. Transformations. Okay, and what we're going to look at today is we're going to look at vertical and horizontal shifts. With cosine and sine graphs. And it's end of May here, and so we should be done in the first week of June, and then have time to do some practice and get ready for the final exam and so forth. Okay, so vertical and horizontal shifts with sine and cosine graphs. It's basically what we're going to look at today. So let's bring up Desmos here. Oops, that's my course outline. We want this other one. All right, so first of all, we're going to set up our window like we did last time, but let me get my example questions up here on the other page. I kind of messed that up. Where are you? Okay, we'll get that up here, and then we'll get set up. There it is. Okay, so we did a bit of this the other day. Okay, so let's set our window up. So let's go here to the wrench, and let's change this window. For our x-axis, we'll just go from 0 to 270, or sorry, 270, 720. That's two periods, or two circles. And then here we'll go from, oh, that's the y-axis. I don't want the y-axis like that. 0, let's go from -4 to +4. Change the wrong one. X-axis, that's the one I want to go to 720. We want to do it in degrees. Okay, so now we're going to start off with the y equals sine x graph. And there it is. There's two periods of it. Now what we're going to do is we're going to add a number to the x. So we're going to put it in brackets. So we're going to do y equals sine bracket x plus some amount of degrees. Let's say plus 30 degrees. Or let's do plus 70 degrees. And you'll notice what has happened here. Okay, so here you can see it's 0, 110. Here it's 0, 180. So you can see that it's shifted backwards. Didn't actually shift forwards. It shifted backwards 70 degrees. Okay. What if it's negative? Let's do y equals sine x plus, minus 70 in brackets. I'll do the sign first. Sorry, guys. Okay, so you can see now the green one has actually moved up 70 degrees. So this, instead of being at 180 here and 0, I can get it right on, I don't know, right there. It's moved up to 250, which is 180 plus 70. So notice that the negative value has shifted forwards and the positive value has shifted backwards. So it's kind of a reversey type thing of what you would think. Okay, so that value that goes with the x in the brackets shifts it horizontally along the x-axis, changing the x-intercepts. Okay, instead of 0, it's 70, 0, right? Instead of 0, 0, 70, 0. Instead of 0, 180, 0, it's 250, 0, and so forth. Still have, so it shifts the graph. So let's summarize that here. Let's shrink this down. Oops. Let's shrink this down and open up our note thing again. And there we are. Okay, so what we're doing is we're comparing y equals sine x or y equals cos x to y equals sine x plus c. Okay. Okay. Or I guess we can, or the y equals cos. Let's see. Okay. And what we can say is the c value shifts the graph of sine or cosine, we'll just call it the graph, horizontally. Okay. If c is positive in the brackets, then the graph moves back or moves left or shifts left. We'll say shifts left. The amount of c. If c is positive in the is negative in the brackets, oh, I can't spell. Then the graph shifts right. The value of c. So what they often do is they will change, they'll actually write it out as a negative c here so that then they can say, well, they'll often write it out with a negative rather than a positive in here. So often y equals sine x minus c is how they write it. They'll often write it with the minus in there rather than the plus. Okay, but that's the C value. Now we'll do the one where we don't have brackets and we just add it. Okay, the vertical shift. So let's shrink this down. Let me just pop my preview up so I can see how much time I'm throwing into this. Okay, so that I can keep track. There we are. We're about 10 and a half minutes. Okay, so if we go back to Desmos here, and now we're going to just type, let's get rid of these two. Now let's just do y equals sine x. And then let's just add 1 to it. Okay, that's, we're not adding it to the angle, we're adding it just 1. So what has happened? You can see that it has shifted up 1 on the graph. So the maximum is at 2 rather than 1. Same shape, just shifting up. If it's minus, it goes down. So minus 3. Oh, sorry, let's go minus 2 so we can see the whole thing. Okay, so that's shifted down 2. Rather than being there, 1, 2, it's right there. It's at negative 1 rather than positive 1. Okay, so that is the vertical shift that happens. Pretty straightforward. So let's go back to our notes and summarize that one here. So we're going to compare here next. We're going to compare y equals sine x to y equals sine x plus 1. We'll call D, or y equals cos x. Well, sorry, let's keep it sine, sorry. Minus D. Okay, so the D value of the graph, we know, shifts the graph vertically. Okay, thus, we can say positive D shifts upwards. The value of D. And negative D shifts down the value of D. So we can generalize now. We can get, let's combine. So if you combine them, if you combine all 4 transformation possibilities, I can't spell possibilities, there's 2 S's, I know. The equation looks like this. Okay, we would have our general equation y equals a sine b bracket x minus, they usually use the minus rather than the plus because of that opposite shift thing, plus d. Okay, and we know if we're summarizing that whole thing combined together like that, this is the Okay, so if we know a vertical shift, horizontal shift, okay, and it's the opposite direction of what's inside the brackets. So a negative inside the brackets would shift it forward, right. A positive inside the brackets would shift it left. Okay, this is period determination. Okay, and we use 360 over B, and this is the amplitude. How high the graph goes. Okay. So that's pretty not that hard really. Let's do some examples of analyzing. It's like, what kind of questions are they going to ask, or I'm going to ask you? What kinds of things am I going to expect you to figure out here? Well, let's do a couple practices using this general idea here. Okay, so let me just bring my notes up here with some extra examples on them. Okay, so let's do one on the next page here. Okay, so let's say describe the shifts period and amplitude of the following graph as it compares to, let's go, the y equals cosine x graph. And let's say my example is, okay, let's say we have y equals 4 sine 2 bracket x minus 30 degrees. I got to put a degree symbol in there. Close the bracket, plus 1. Period. Okay, so this is okay, so we just look at that. We say, okay, A equals 4, B equals 2, C equals, okay, it's a minus in there, so we can say that it equals 30, and it's going to be going, okay, if it's negative, it's going to be, we'll just write in here, okay, if we put a negative there, we know that that's going to be going to the right. And D is 1. Okay, so we can say, therefore, the amplitude of the graph is 4. The period is 360 divided by 2, which equals 180 degrees. The horizontal shift is 30 degrees to the right. And the vertical shift is one unit up. And there we go. Just analyzing that simple one. Okay. Okay, so I'm going to put one up here. See if you can do it. And then I'll work it out exactly the same kind of idea. So let's say I give you this one. Let's say I got y equals, then I'll show you a little tricky one that happens sometimes. Try this one. Okay, y equals sine 5 bracket x plus 60 degrees bracket minus 3. Okay, if there's nothing in front, we assume that it's a 1. Okay, I'll give you a second or two to try that. I'm going to pause here for a second while I look up I got to find a couple more practice ones here that we want to try. Okay, I found a couple other kinds that we're going to look at here in a minute. So, okay, what is the amplitude A equals 1. Therefore, the amplitude is equivalent or the same is 1 unit high. B equals 5. Therefore, 360 divided by 5, which if we do that, that's going to give us 72 degrees, is the period of the function. Or graph, if you like. Okay, and we know that C equals 60 degrees. Okay, it's going to be negative, and it's going to be to the left. Okay, if we pretend it's the opposite side of that, so that means the horizontal shift is 60 degrees left. Or back, if you like. And D, there is a negative 3, so D equals negative 3. So the vertical shift is down 3 spaces or units. Okay, now they'll do the opposite thing. They could give you a bunch of what has happened and ask you to write the equation. Okay, so let's do an opposite type of question. Example like that. So what if I said, find the equation for a sine graph that has an amplitude of 4, a period of 120 degrees with a vertical shift or let's say with a shift down 2 spaces and a movement back 40 degrees. Here. Okay, so let's define everything that we can define here. Okay, so we know that the amplitude is 4. So that tells us that A equals 4. The period is 120. So we got to figure out, so we got to remember that 360 over B is equal to the period. So we got to solve this equation. So we've got to multiply B on both sides. Okay, and then divide by 120. So now we know that B equals 3. Okay, so 120 plus 120 plus 120 should give us 360, or 360 times 3 times 120 should give us 360. C, okay, there is a movement back. Okay, so that means backwards. So that means it's going to go left 40 degrees. So the sign is going to, in the brackets, okay, is going to be positive. Okay, and D is down 2 spaces, so -2, down. Okay, so if we take our general equation, y equals a sine, or was it cosine? What did I have? Sine graph. Okay, sine b, oops, I was going to put brackets here. Let me get the b in there first. Bracket x minus c plus d. Okay, so y equals, okay, a was 4 sine 3 times x. Okay, it's going to be positive in the brackets, plus 40 degrees and -2. And there's the equation for that given information. Okay, so there's that kind of question that they have. Okay, let me just pause again here for a second. Actually, let me give you one to try, and then I'll pause and then I'll look up, see if there's any other kinds of questions that they have. So try this one. What is the equation of the sine graph that has shifted back 30 degrees and up 2 spaces has an amplitude of 1 and a period of 90 degrees. Okay, so try that one. I'll give you a couple minutes. I'm going to pause here and see if there's any other types that we need to look at.